Good morning to all of you. I am Dr. Alok Agrawal, and today we will be discussing a new topic that is on Morse test of your course Internal Combustion Engine, having subject code ME501. So this is very important topic in practical also. Where we will be doing in our practical lab also. Morse test we will perform in our practical test on petrol as well as diesel engine. Okay, so this is very important theoretically as well as practically. So let's start with Morse test. This is one of the most important tests performed in SI engine. That Morse test. So what it is? It is the test can either be used to determine the indicated power or friction power. So this test is performed to evaluate the indicated power or friction power of a multi-cylinder engine, IC engine, by cutting each cylinder in turn. Now it is used to determine the indicated power and friction power, because brake power can be easily determined by the help of dynamometer that we have seen. So for multi-cylinder engine, if you want to evaluate the indicated power or friction power, this cylinder plays a important. This test plays an important role. Okay, and how it is performed? It is performed by cutting each cylinder in a turn. Means, for example, if you are working on four-cylinder engine, then you have to cut each cylinder turn by turn to evaluate the indicated power or friction power of each cylinder. Okay. So in case of SI engine, today we will be taking a case study of SI engine. So in case of SI engine, each cylinder in turn is made inoperative, inoperative by shutting the spark plug of the cylinder. Okay, we will cut off the spark plug of the cylinder to make it inoperative. Okay, and in case of diesel engine, what we have to do? We have to do by cutting the supply of fuel by fuel injector. So in both the engine, this Morse test can be performed in SI engine by cutting the spark plug connection, and in CI engine by cutting the fuel injector system. We can make each cylinder turn by turn inactive. Okay. So what there are some assumptions that we have to take. So what are the various assumptions? The assumptions are that a four-cylinder SI engine is coupled to a dynamometer. It is coupled to a dynamometer. Throughout the test, the engine run at constant speed. So we have to make the engine run at constant speed. We have to consider that pumping and mechanical friction losses are same whether the cylinder is working or not. Okay, actually it is most of the time it is near about same, but in some time in practically there is a difference between the working and non-working engine. Okay, so but here we have to assume that the pumping and mechanical losses are same for all engine. Okay, again the throttle position has to be kept constant throughout the test, which we are not allowed to change the throttle position of the engine. Now let capital B is the brake power of engine when all four cylinders are working. Means when sparking is occurring in each and every cylinder, then the total brake power generated by the cylinder is capital B. Now here comes the trick that B1 is the brake power when we make inactive cylinder number 1 and rest 3 cylinder are on working condition. Means they all are producing energy. Sparking is occurring in cylinder 2, 3 and 4. But in cylinder 1 we are not doing sparking by cutting off the connection. Okay. Similarly, power B2, capital B2 is the brake power of the engine when cylinder 2 is cut off and 3 and 4 respectively. Okay. B3 and B4 are for cylinder 3 and cylinder 4 cut off respectively. Now, let I2, I3 and I4 are the indicated power developed by the engine, I1, 2, 3 and 4, and the corresponding frictional power is F1, F2, F3 and F4. So see this B, whatever is given, that B, capital B, it can be the reading can be taken by dynamometer. B1 reading also can be taken by dynamometer. Like this, all the 5 brake power can be the reading can be taken by the dynamometer, and we cannot say anything about till now. We cannot say anything about the indicated power and brake friction power. We are just assuming that these are the indicated power of 4 cylinder and these are the friction power of 4 cylinders. Okay, so from knowledge we already have, we know that brake power is a difference between indicated power and friction power. So if you are talking about the brake power of the complete engine when all the 4 cylinders are working, I1, I2, I3 and I4 are the complete indicated power of the cylinder, and F1, F2, F3 and F4 are the summation of these are the total frictional power of the engine. So this is the total indicated power of the engine, this is total frictional power of the engine, and this is the output of the engine in terms of brake power. This reading has been taken from the dynamometer. Capital B is taken from the dynamometer. Okay. Again, what is our aim? Our aim is to evaluate the indicated power and friction power of the engine. Okay. Now give this equation 1. Now what will be the B1? B1 is what? When cylinder 1 is cut off. So when cylinder 1 is cut off, there will not be any combustion in cylinder 1. So indicated power will be 0. So I1 will be 0. So what will remain? I2, I3 and I4 will remain. But it has been assumed that friction power will remain same whether the engine is working or not. So friction power will remain same, that is F1 plus F2 plus F3 plus F4. So B1 will be like this. Give this equation 2. I hope it is clear. B1 means cut off at cylinder 1, and when there is cut off at cylinder 1, there will not be any indicated power developed in cylinder 1. So total indicated power will be the summation of indicated power developed in cylinder 2, 3 and 4. Okay. Similarly, okay, so first what we are subtracting equation 2 from equation 1. What we are getting? Left hand side b1 b minus b1, and right hand side what it will be left? Only I1, because I2, I3, I4 will be cancelled out and friction power will be cancelled out. So we get one equation, that is B minus B1 is equal to I1. Give this equation 3. Similarly, what we are doing, we are doing for B2 by cutting the cylinder 2 by 3 and 4. We get B2, B3, B4. Means in case of B2, what will be there? I2 will not be there. I1 plus I3 plus I4. This thing will remain same. In case of B3, I3 will not be there. In case of B4, I4 will not be there. Okay. Rest three will be there, because 3 cylinder are working. It means 3 cylinder energy is getting produced. So similarly, we have written B minus B1 is equal to I1. Similarly, we can write B minus B2 is equal to I2. B minus, give this equation 4. B minus B3 is equal to I3, equation 5. And B minus B4 is equal to I4, equation 6. Okay. So likewise, the way we have written equation 3, we can also write equation 4 and 5 and 6 for when cylinder 2 is cut off, 3 is cut off and 4 is cut off. Now adding equation 3 to 4, when we will add this 3, 4, 5, 6, all the 4 equations, what we will get? We will get right hand side 4b, 1, 2, 3 and 4, 4b minus b1 plus b2 plus b3 plus b4. And in right side what we are getting? I2, I3, I4, I3 and I4. So total indicated power will be right hand side I2 plus I3, I1 plus I2 plus I3 plus I4, and left hand side will be 4b minus b1 plus b2 plus b3 plus b4. Now see, this b and this b1, b2, b3, b4, all the values can be calculated with the help of brake power or dynamometer. Sorry, all the brake power can be calculated with the help of dynamometer. So right hand side complete thing is known to us. B is known to us, B1, B2, B3 and B4 is known to us. So with this known value, we can easily calculate the indicated power of the engine. And once we get the indicated power of the engine, the friction power can be calculated by I minus B, that is indicated power minus brake power. Okay. So in this way, by performing the Morse test, by cutting each cylinder at a turn, we can we'll be able to evaluate the value of indicated power and friction power. Okay. Now let us solve one problem related to this. Very simple problem, very small problem. A gasoline engine working on 4-stroke develops a power of 20.9 kilowatts. So total brake power is given 20.9 kilowatts. A Morse test was conducted on the engine, and the brake power was obtained when each cylinder was made inoperative by short circuiting the spark plug are 14.9. Means what is this 14.9? When cylinder 1 is cut off, that is B1. This one is B2. This one is B3 when cylinder 3 is cut off. This one is B4 when cylinder 4 is cut off. The test was conducted at constant speed. This is our assumption as well. Find the indicated power, mechanical efficiency, friction power, and brake mean effective pressure when all the cylinders are firing. Now, indicated power, capital I is required. That will be the summation of I1 plus I2 plus I3 plus I4. Mechanical efficiency, brake power by indicated power, friction power, indicated power minus brake power will be there. Brake mean effective pressure. For calculating brake mean effective pressure, bore of engine is given 75 mm and stroke is 90 mm. Also, the engine speed is given 3000 rpm. So this last part is quite easy, that we have already solved in many problems. So the important thing is to calculate the indicated power and brake power by this value of 5 brake power. Okay, so this is capital B, B1, B2, B3, B4. It is written here, all the given conditions are written here. So moving to the equation that we have seen, indicated power 1 will be total brake power minus brake power when cylinder 1 is cut off, 20.9 minus 14.9. Similarly, indicated power 2 is 6.6 kilowatt. Indicated power 3 is total brake power minus when cylinder 3 is cut off 1 to 4. Indicated power 4 is total brake power minus when cylinder 4 is cut off, that is 1 to 3, 20.9 minus 14.5, that is 6.4. So we get indicated power 1, 2, 3, 4 cylinder, first cylinder, second cylinder, third cylinder, fourth cylinder. When we'll add all the indicated power, we get total indicated power, that is 25.1 kilowatt. Once the total indicated power is calculated, mechanical efficiency of friction power will be calculated by indicated power minus total brake power, that is 25.1 minus 20.9, that is 4.2 kilowatt. Mechanical efficiency will be calculated by brake power by indicated power into 100, 83.3%. Simple calculations. Brake mean effective pressure. We know the formula, brake power into 60,000 upon LA NK. L is given, we have to convert it in meter. 90 mm is equal to 0.9 meter. Area is pi by 4, d square, d is 75 mm, so it can be written as 0.075 meter. Again, this is 4-cylinder engine, it is given in the problem, 4-stroke engine and 4-cylinder engine. So capital N will be, small n will be capital N by 2 and number of cylinder K will be 4. So by solving this, we will get 5.25 into 10 to the power 4, which can be written as 5.25 bars. Okay, this is very simple problem on the theory of Morse test. Okay, so this is all for today's class. In next class, we will take the last topic of this unit, that is heat balance sheet. Okay, thank you very much.